Okay, did you guys have enough time to look at it? Yes, but not do it. So you are gonna have some kind of quiz next week, and some of this stuff is gonna be maybe like this. And this one, basically putting the three integration pieces together. Glenn, what's the integration of that? This whole first term. What's the integration of that? Whose derivative is 1 over x? What's ln x? So Zach, what's the integral of this one? If this was 1 over x plus 1, okay. Any integral of positive sine 7x? Positive or negative?
Or negative.
And it didn't do u substitution because this is, the derivative of this was just a number. When I did the derivative, I would have had to multiply it by chain rule. So integrating, I need to divide by chain rule. The tricky one is the last piece. Anyone know how to integrate that one? Evan?
Well, I made 1 over e to the 5x, 1 or e to the negative 5x.
So
and then
what's,
I got 1/5 e to the negative 5x. Positive.
so what he just said was, he rewrote it like that. Yes, totally yes. And said, well, the integral of e to the negative 5x is e to the negative 5x divided by the derivative of stuff. So divided by negative 5, so that subtraction that was there actually becomes positive. So that big old mess is 3 natural log of absolute value x minus 5 minus cosine 7x all over 7 plus e to the negative 5x over 5. There's all those pieces. Okay. And I just want to make sure we didn't go over this super well on the homework. I just showed you the process. Just want to make sure we actually do one of these. So acceleration is 32 feet per second squared. How do I get velocity? Well, integrating acceleration. I'll write it the physics way, v sub 0 instead of plus c, so initial velocity. I didn't give you initial velocity, but I did tell you at 2 seconds velocity is 10, so and position is the integral of velocity, and velocity that I just figured out. V of 0, sorry, I solved for that. Integrate. And again, using physics or pre-cal. Oh, initial position or initial height. And in this problem, I said in 2 seconds, it's 5 feet underground, whatever, 25 times 400. Oh, 25 times 54, I don't know, 270, I really don't know. So the plus C is different each time, and it's an entirely different entity. Like integrating acceleration, I had to know initial velocity, or at least some velocity that I could anchor down somewhere. And integrating velocity, I needed to anchor down some position that I knew at some point in time. I could very well be wrong. Sorry, did I do my arithmetic wrong? Okay, so just wanted to show that. All good? So want to move on to today. Larger than life problem. So these are questions that are expensive on the AP exam. So first step in this is called separation variable. What's the question?
When you solved it before.
Okay. Solve for the differential equation, and they will say they'll say of the form y equals f of x. Give me the equation that has this as the derivative. Okay, so they're called separable functions or differentials that we solve by separating the variables. Y's go with y's, x's go with x's, and dy and dx are basically the width of the rectangle. This side I'm going to have x dx, this side I'm going to have 1 over the square root of y, cosine squared, square root of y. That's step 1. If you don't do step 1, then immediately on the rubric that I have, they immediately say, no suit for you, 0 out of 5. Okay, I will do the hard one for you. They integrated that side. Raise the power divided by the new power, add c. The other side, we need to do something like Evan did with that first warm-up question. Does anyone see how we can rewrite it that it might make a little more sense? Sadie, you see something or no? No.
Whatever integral 1 over y dy times 1 over cosine squared over y.
Okay, well, what's different? Like, how do I change it so that I can see how to integrate this?
Always, you just like use substitution.
I I wanna, there's three of you in a row that see something, what do you guys see? Sebastian, what do you see?
Oh, is it like you have to change it to secant square?
That might help. So. And Zach was saying, there's something about that square root of y thing that maybe we'll do use substitution with that. And I'm a purist, I prefer to keep the letters always separate. Yeah, Amelia?
Why would u be square root of y, not just y?
Okay, well, let's try this. This would have become secant squared square root of y. It's now secant squared u. And like, if u is just y, was there any reason that we should have changed the letters? Okay. I mean, if it's one for one, which we will do and it will be useful then, I don't see it useful here. Okay, so I still have 1 over the square root of y dy to replace. That's right here. So George, what is the integral of secant squared stuff?
So you gotta do
Integrate,
the integral is secant square.
Whose, so that one is just, whose derivative is secant squared? Tangent. 2 tangent of u, well, I'm gonna put that back in. Okay. And I didn't give you an initial value, but as Alex said in the beginning, what are we solving for? I didn't say, so I want to find the equation y equals. There's all kinds of crap attached to this y.
Just because it's, okay.
So, what do I do next? To get y out of there. Ray, what's the next thing? Divide by 2. I'm gonna be irritating. C is an unknown pile of stuff. So this is unknown pile of stuff divided by 2. I'm not gonna write that. I'm just gonna be like, oh, it's a different pile of stuff now. That'll change once we plug in a value, but, Adrian, I still have, y is still trapped. How do I undo tangent? Anyone at the table? How do we undo tangent? Go on, friend. Michael? Okay. And arctan applies to the entire side of the equation. You lose lots of points if you stick on plus c at the very, very end. Plus c is wrapped inside there.
I was explaining on why there's only, you only have C on one side, not the other.
Okay? Did you get? So it's unknown junk on this side, unknown junk on that side. We're just gonna keep it all over one side. And we're gonna usually put it with x because we usually wanna solve for y. Oh my goodness, so I still don't have y by itself. This is completely weird. But there. Gross. And in real life, when you're modeling equations, Okay. Hard step in this one is separating the variables. How do you pull them apart? Okay, so it's easier to do the drawing when you write it down. So if you guys could write down on the whiteboards, how are you pulling these guys apart? You get when you fully separate them, you get X's on one side and Y's on the other. Kyle, can you grab a marker off the board?
Wait, no, wait, you can have multiply this. Do the x minus y is just e to the x times e to the negative y. So you have the x over the y. Probably
Okay, guys, write it down. How did you separate them? See one group's answer. Evan? No, we got this. Okay, so I saw at least 5 answers that were correct. And different people started in different places. But that's it. Like, first thing, pulling apart that exponent in the first place, you need to get comfortable with that. And you need to be good with going both directions with this. The warm-up question that Evan saw through right away, it was like 1 over e to the y, or e to the 5x. I don't know what that is, but I can integrate e to the negative 5x easily. So you need to be flexible, moving it up or down, however you need to. But now that we're here, now the problem's easy. The hard part was step 1. The integral of e to the stuff is e to the stuff. There's nothing even like gene-woolly about it. E to the stuff is e to the stuff. Okay, plus c. And I only put it on that side. Okay. Who gets to decide? Claudia. Should I plug in, and there is no right answer, there's just 2 different choices. Should I plug in my initial value now in cell for C, or should I get y by itself first? Your choice.
Y by itself.
Y by itself, okay. How do I do that? Natural log. So Kari says, natural log both sides, and you gotta take the whole group that's on the right. natural log of e to the y is y. Okay. Alright, now we have y by itself. The last thing I need to do is plug in this. Okay. How do I, Claire, how do I plug in that coordinate?
0 into e to the x, and then ln2 to y.
Okay, what is e to the 0?
1.
So Franco, what does it look like c is?
I'm not sure yet. Still writing it down.
Sita?
C would be equal to 1 because you can like exponentiate both sides to the e and just take the 2.
Or you can just say the insides are equal to the insides, so 2 equals 1 plus c. Yes, Franco, yes, he's doing. That's
Okay,
good.
we finally got there.
Okay, don't leave it like this, you're not finished. In my work, I always put the asterisk on it, like right here, I am plugging these values in. Right here, I can no longer just say, oh, it's an unknown pile of junk, I'm gonna just double it and it's still an unknown pile of junk. Can't do that anymore. I've anchored it down to a spot, plug those things in, now everything matters. But my answer is y equals natural log of e to the x plus 1. That is my initial value problem. And in the grading rubric of these things, if you do not separate the variables, 0 out of 5, which is huge. If you forget plus c, the maximum you can get is 2 points. And those 2 points would be to separate the variables, and if you did the integration correctly, that might give you 2 points. Okay. Other than that, good enough. Okay. Roman, how did you separate?
divide both sides by square root of y, multiply both sides by the x.
Okay. All right, and personal preference, you can move the 4 or not. Your choice. It's just a 4, I don't know where it is. Alrighty then. So, 1 point for you, separated the variables, excellent. Kyle, can you integrate the left side?
Negative.
So raise the power first. What is the power?
Negative 3/2.
Negative 1/2.
Negative 1/2. Yeah.
So raise the power from negative 1/2 to,
1/2. So there's root y.
and then divide by the new power.
Over 2 or 2.
Dividing by 1/2 is multiplying by 2. Okay. The other side, see, I probably need some u substitution. What is your suggestion of the u value?
Natural log x.
Perfect. Okay, so substituting out, I haven't done the integration yet. It's, I'm gonna put the 4 on the outside. Okay. U du. Oops. So Naomi, how do I integrate this, the right side?
Raise the power and divide by the power, so u squared over 2.
And then 4 divided by 2, I'm just cheating and not writing so much. What am I forgetting?
Let's see.
She was about to be like.
No, I always do
Yes.
that. I always forget.
So, I forgot, I didn't forget it, but yes, plus c. And I don't want things in terms of x, or u, I want them in terms of x. Okay, I gotta remember my initial value was y of e equals 1. Okay, did I solve for y yet, Alex? Cameron, you get to choose this time. Do I plug in and solve for c now, or do I get y by itself? Plug it in, all right, good idea. For myself, I put the little asterisk, like, now things are solidified. So, the y value is 1, so 2 times the square root of 1 equals 2 natural log of e squared plus c. How will that work? What does c come out to be? What's natural log of e? E to what power is e to the first 1? 1 squared is 1, 2 times 1 is 2. What is c? Oh, well, that's nice. C is 0. So now that I've solved for c, I'm going to go back to where I had my little asterisk, and I'm going to say, okay, well, the equation is 2 square root of y, and plus c, that c was 0. Now I got to get y by itself. Jason, what do I do?
Cross out the 2's.
Cross out the 2's.
Square both sides.
Square both sides, and that's weird. And they can also write it like that. Okay. So these kinds of questions are often on free response question, and they are more than half the points on that free response question. And they're not hard, but seeing through step one is usually the hardest part. This was one of the more difficult questions that I had to grade. Lots of kids got zeros because they couldn't get started. But once they got started, they got a 9 out of 9. So the bell curve scores on that one went like that. Lots of people with zeros, not many in the squishy, comfortable middle. And then the next question I graded was like this. Like, the distribution, the average still came out about 5.5, but, you know, I was much happier for like, yay! Anyway. Okay. I don't want you to do these, I want to just talk about strategy. How would I integrate the first one? What's the first step we should do that is not calculus at all? Amelia? Divide and conquer. Don't leave it like that. How do we deal with exponents over exponents? Subtract them. So, and this one, I could write it as 5 over e to the 5x, but I would do what Evan did in the very beginning and make it like that. Now they're easy to integrate. So please remember, divide and conquer is a very strong and powerful force. Just use some algebra 1, cut it up into little baby pieces, and it's much easier. How would we do number 2? Is that do substitution? No, what is it, Evan?
Multiply the 3x out.
Just distribute and make 3x squared minus 9x and integrate. This one, what the heck? Impossible. Use sum. Tangent is gonna be the u value and 1 over cosine squared. Well, that's another way of saying secant squared. The derivative of tangent is sitting there, and they will make it look different. All right, I wanna give you guys the exit card.